Most AI world models have a massive problem. Turn the camera away for 10 seconds, and half the scene disappears or completely changes. Ant Group just released LingBot-World, and it's different. This thing remembers objects for a full 60 seconds off-screen. It calculates physics for things you can't even see, like where a car should be after it drives out of frame. And it runs in real time at 16 frames per second with instant WASD controls. It's a 28 billion parameter model that's fully open source, and it might be exactly what AI world simulation has been missing. Before we jump into the examples, let me hit you with the benchmark numbers because they're legitimately impressive. The researchers compared this against Yume 1.5 and HunyuanWorld 1.5 using VBench, which is the standard benchmark for evaluating video models. LingBot-World scored 0.88 on dynamic degree, which is massive compared to 0.76 for Yume and 0.72 for HunyuanWorld. That's a huge jump, and you can actually see it in the generations. The scenes are way more alive and responsive. It also beats both of them on imaging quality at 0.67 and aesthetic quality at 0.57, while keeping motion smoothness rock solid at 0.99. The overall consistency score of 0.22 is also the highest, which matters a ton when you're generating minute-long videos. These aren't just small improvements, this is a genuine leap forward in what world models can do. All right, let me walk you through the examples from their project page because they're absolutely wild. Check out this first generation. It's almost a minute long. See those WASD indicators at the bottom left? That's showing you the key inputs in real time. Press W, the camera moves forward. Press A, it rotates left. D goes right, and S moves backward. You're basically controlling an AI-generated world on the fly at 16 frames per second. Look at this where it's climbing stairs and moving around. It feels genuinely responsive. The latency is under 1 second, so the interaction feels immediate and natural. Now here's where it gets crazy. See this dinosaur scene? Watch what happens as the camera moves. Holding S moves backward, then tapping D and A to rotate. The dinosaur isn't just sitting there frozen, it's actually moving like it's alive. Here's the impressive part. You can pan the camera completely away from the dinosaur, look at something else for like few seconds, and when you come back, the same dinosaur is there exactly where it should be. Most world models would either delete the dinosaur or completely change the scene. This one remembers. That's the object permanence feature they talk about in the paper, and it works for up to 60 seconds of the object being off screen. Here's another example showing off the same thing. This is a character on a horse, almost like a Red Dead type vibe. You can rotate the camera 360 around the character while they're riding, seeing them from every angle. The horse is moving, the character is moving, but you're controlling the camera independently. The generation stays consistent no matter how you rotate. Most world models can barely handle 10 seconds before things start warping or the scene completely changes. This maintains coherence for the full minute. Check out this POV snow skiing scene. You can see the skis at the bottom of the frame, and as you move the camera, the person is actively skiing down the mountain. You can look up, look down, pan left and right, and the skiing motion continues naturally. The physics understanding here is really impressive because it's not just generating random motion, it's understanding that this is a first-person skiing perspective and maintaining that context throughout. Now here's where it gets crazy. See this long horizon memory in action? This is a futuristic cityscape scene. Now watch what happens when the view pans left and right. Buildings go out of frame, and when it pans back, the exact same buildings reappear. There's no degradation, no changes, it's maintaining spatial memory of the entire scene. And remember, all of these generations are 1 minute or longer. Most world models give you 5 to 10 seconds max. This maintains quality for the full duration. Here's where it gets even better. You can give it a completely realistic photo and it'll animate it. At the start, no keys are being pressed, but watch. People are walking around, cars are moving. It's not just a static image, it's been animated into a living scene. Now keys start getting pressed and the camera moves far to the right, completely out of the original frame. When it comes back, everything is exactly the same. Then it goes far to the left, and again, when it returns to the starting position, the scene is identical. It's preserved the memory perfectly. This is actually solving one of the biggest problems with world models, which is that catastrophic forgetting issue they mention in the paper. What's really cool is that this model was trained on two types of data: real-world footage and gaming data. It actually understands the difference and applies the appropriate physics. Give it a game-style image, it generates with game physics. Give it a realistic photo, it uses real-world physics. Look at this example from their page. It's a character flying between buildings like a superhero. The model recognizes this as a gaming scenario and generates accordingly. You can change the camera angle to see the character from the front or side, and it maintains that gaming feel throughout. Here's a sketch-style painting input. It generates the world based on game-like physics, and you can interact with it using WASD keys like it's an actual playable game. The consistency holds for the full minute, which is genuinely impressive for this art style. And check out this one. A girl on a flying broomstick over mountains and water. You can explore from every angle, see her from the front, from the side, from above. The quality is really clean, and it maintains that gaming world aesthetic perfectly. Now switch gears to realistic inputs. Here's a POV paragliding scene. Because this is a real-world scenario, the physics change. Press S, you move backward. D rotates one way, A the other, W moves forward. The physics feel grounded and realistic instead of game-like. Same thing with this squirrel climbing a tree. You can watch from different angles as it climbs, and the model is applying real-world physics to how the squirrel moves. The intelligence here is actually pretty impressive because it's context-aware and adapts based on the style of input you give it. Let me show you the off-screen memory one more time with this cat example from their page. The cat is on screen, then the camera rotates completely away and stays on the carpet for a while. When it finally brings the camera back, the cat is sitting there right in the same spot. That memory retention is so important for creating believable interactive worlds. Now this is a big one. 10-minute video generation. This clip shown is near the end, around the 8 or 9-minute mark. Scrubbing back to the beginning, around 2 to 3 minutes in, look at the quality here. Now jumping back to the end at the 9-minute mark, the consistency is still there. No artifacts, no degradation. Being able to generate 10 minutes of coherent video without falling apart is actually kind of insane. They've also nailed physics interactions. In this scene, a cat is walking through a room. When it enters a sunny spot, you can see the lighting change on its fur. When it moves into shade, the lighting adjusts again. And when it encounters furniture or obstacles, it stops. It doesn't just phase through objects, it actually understands physical boundaries and gets stuck, forcing you to navigate around them. That level of physics understanding is a huge step up. Now here's a feature I think is really cool: promptable world events. You give it an image, like this dragon scene, and then you can add text prompts to trigger specific events. Select fireworks as the event, and boom, fireworks appear around the dragon as it flies. Select storm, and a storm condition rolls in near the buildings. Choose shield, and shields suddenly appear in front of the flying dragon. Choose ice world, and the entire scene transforms. The dragon turns icy white, and the buildings become frozen. It's like adding dynamic layers to the world on the fly. Same thing with this fountain scene, which is a realistic photo. Add the frog event, and when the camera moves, there's a frog sitting there. Switch to fish, and fish is swimming in the water. Choose flower, and flowers are floating in the stream. Select pixel world, and it converts everything into pixel art style. Being able to modify scenes with text prompts like this opens up so many creative possibilities. Now this is about the most. There's an action agent feature, which is basically an autonomous AI that plans and executes actions within the generated world. You can see this astronaut walking on Mars with agentic autonomous movement, or this knight walking through a castle, all planned and executed automatically. It's like the AI is playing its own game within the world it generated.
And here's something I didn't expect: 3D reconstruction. You give it a video of exploring a room with WASD controls, and it builds a 3D model of the entire space in real time. You can zoom into this 3D model and explore it from any angle. See the table, the cupboard, different objects. It's fully interactive. Same thing with outdoor scenes. It generates a 3D point cloud that you can navigate and interact with. This validates that the model actually has geometric understanding. It's not just generating random pixels. They use large-scale 3D reconstruction models on the generated videos to create these point clouds. So how does this actually work under the hood? LingBot-World is built on the WAN 2.2 architecture, which is a 14 billion parameter image-to-video diffusion model. But here's where it gets interesting. They use a mixture of experts designed with two experts totaling 28 billion parameters. One expert handles high noise, early denoising steps and focuses on global structure. The other handles low noise, later steps for fine details. But only one expert is active at a time, so inference cost stays similar to a 14 billion parameter model. They trained it in 3 stages. Stage 1 established the general video generation capabilities using large-scale video data. Stage 2 injected world knowledge and action controllability using something called plucker embeddings for camera control and adaptive layer normalization to inject action signals into the model. This is where it learned long-term consistency and spatial memory by progressively training on videos from 5 seconds all the way up to 60 seconds. Stage 3 converted it from a bidirectional model to an efficient auto-regressive system using causal attention and few-step distillation, which is how they got it running in real time at 16 frames per second with under 1 second latency. The training data came from a hybrid pipeline: high-quality real-world videos, game engine recordings with precise action labels synchronized to frames, and synthetic data from Unreal Engine with perfect camera pose ground truth. They also used hierarchical captioning with 3 levels of detail to teach the model to understand scenes at multiple granularities. As for availability, they just released the code and model weights on GitHub a few hours ago. The cool thing about being built on the WAN 2.2 backbone is that there are already quantized and distilled versions available, which means you could potentially run this on consumer-grade GPUs if you use those quantized versions instead of the full-weight model. Right now, they've released the base CAM model, which lets you generate 480p and 720p videos and control camera poses. The ACT model, which will let you control character actions like moving forward and backward, hasn't been released yet. Same with the World Fast model, which will be a distilled, faster version. But what's available now is already incredibly powerful. All the installation instructions are on the GitHub page, and I'll drop the link to both the GitHub and the project page in the description below. Honestly, I think Ant Group is having an absolute moment right now. They keep releasing groundbreaking stuff, and the fact that they're open sourcing everything makes it even better. If you want to check out all these examples yourself or download and try the model, all the links will be in the description. And if you found this video helpful, hit that like button and drop a comment. I'll catch you in the next one.